Hello everyone, welcome back to our video classes. Hello everyone, welcome back to our video classes, and today we are going to start with the second part of Is Matter Surround Us Pure? Okay, and before starting this video, I think you have watched the previous videos and the first part of Is Matter Surround Us Pure. So in there we have discussed about what are the pure substances and how to separate them out and all these things. Okay, all of them are very important, so please watch them first. After that, start this video. Now, you know what you have to do. If you have any doubts regarding anything, any concepts or anything that you are facing trouble with, you just have to write it on the forum. Okay, then definitely one of us will definitely reach you. Now, today we will start with the main topic is the physical and chemical change and the comparison between physical and chemical change. So physical and the chemical changes, these are the main topic that is the thing that we need to learn, because this is the basic of chemistry. Okay, this is the building block of chemistry. If you want to read chemistry, if you don't know about the changes, which one is physical and which one is chemical, this is going to be very difficult for you. The journey after that is going to be very difficult for you. So this is going to be a very important video, and I want your 100% attention in this video as well. Okay, now the first thing about it is, you can see, mainly we are going to come across two types of changes. So changes can be of two types, right? As you can see, one is physical and the another one is chemical. Now, what are the difference in between them, and how do we find out which one is physical change and which one is a chemical change? So this is our USP for this video. Now, if we just start with the physical change, you can see the changes in which no new substance is formed are called physical changes. Now, just try to think about the daily activity that you do. So I think you have seen, like, you have seen ice melting. You have seen ice melting, right? Now, if I ask you, tell me, what is the formula of ice? You're going to tell me, sir, this is H2O, right? Now, if I ask you, what is the formula of water? Because that is what which is getting formed after the ice melts. So that is going to be H2 as well. Now, if I ask you, if I just heat this water, it would get converted into vapor. And if I ask you, tell me, what is the formula of vapor? Then definitely you are going to say, sir, the answer is H2O again. So what is changing in this, like ice to water to vapor? What is the thing that is getting changed over here? Now, to make you understand about it, I have a simple model. If I just try to think about it, okay? So I have not work. Give me a moment. Yeah. So I think you can see that there are some balls inside, like, yeah, these are atoms, okay? Okay, these are atoms. Now, all these things are very close to each other. I am just taking out two of them or three of them, like this. Okay. So when these atoms or these molecules, whatever, okay, whatever you feel like, when they are very close to each other, okay, this thing is the formation of solids, right? When they are getting far away from each other, so we can, like this, then the intermolecular separation is increasing, okay, then they are going towards the liquid state. And when they are moving farther away from each other, then this is the gaseous state, isn't it? So in the molecular attraction in between them, this is getting changed. When an ice is getting melted, what is changing? The intermolecular force of attraction is getting changed, isn't it? Now, the intermolecular force of attraction, the change of intermolecular force of attraction, that can be reversed back, isn't it? Like, you can change this water to ice anytime. like by just cooling it down, isn't it? By just cooling it down. Okay, so what is actually happening over here? If I ask you what is happening when you have some ice in a beaker, you are after that you have started heating it. Okay, now what is actually happening? Now when you heat a particular substance, you give it some sort of energy, isn't it? And we call that energy as the kinetic energy. So actually what happens is, this is the molecule, this is the intermolecular spaces in between them. When I start heating it, this molecule is absorbing the energy. This energy is getting converted into kinetic energy, and they start moving. They starts moving. When they starts moving, they try to get away from each other, go away from each other, because they have more energy. Think about yourself. When you have a huge amount of energy inside you, you don't tend to live in a particular small place, isn't it? You try to run away, you just try to go to the field and try to play and try to do stuff, isn't it? The same thing is happening for the particles as well. So they try to move. They are not like, they don't have the intention to stay there. They want to go away. They want to run because the kinetic energy is increasing. So as the kinetic energy is increasing, they just want to go away from each other. Now, as they want to move away from each other, they are just increasing the distance in between them, right? And that is decreasing the attraction forces in between them. Let's focus on this. I'm writing it here, okay? When the kinetic energy is increased, what is happening? The intermolecular forces are decreasing, the intermolecular forces of attraction. Okay, those who know about this, about the intermolecular forces of attraction, for them I would rather say we call it van der Waals force of attraction. Okay, so van der Waals force of attraction is one type of intermolecular force of attraction. There are some different types of intermolecular force of attractions as well. Van der Waals is one of them. Okay, inside van der Waals we have three different types of forces. One is Keystone force, you learn about it. Another one is Debye force. Another one is London force. Okay, these three types of forces are there inside the van der Waals force of attraction. Okay, you'd learn about it in your higher classes. So these three forces together are called van der Waals force of attraction, and this van der Waals force of attraction is one of the reason between which acts between two molecules, which is there for the intermolecular force of attraction. Okay. Now, when the intermolecular force of attraction decreases due to the increase in kinetic energy, why the kinetic energy is increasing on the first place? Because the temperature is increasing. Kinetic energy is directly proportional to the temperature. As you increase the temperature, the kinetic energy would increase. Got it? Now, the thing is, intermolecular forces are decreasing. So, the space in between two molecules, so intermolecular spaces are also increasing. As the forces decreases, as the attraction forces decreases, the spaces increases, isn't it? They just want to go away. Okay, it's like your best friend and you, both of you have had some quarrel between you. You would try to stay away from each other, isn't it? That is the same thing happening over here as well. They have high kinetic energy. They don't care about their relations. They have better opportunities. They just want to run away. They just want to, play. They just want to go away from each other. They don't want to stay in a small room, waste their entire day. They just want to go away. Got it? Now, this is what's happening. The space is increasing. Now, for the space is increasing, the state of matter is changing. The state of matter It is getting changed. So this is the entire thing which is happening when you are heating up a substance. And this, the entire thing over here, which we have learned so far, is reversible. Is reversible. Okay. The entire thing is reversible. Wait for a moment. Fine. The entire thing is reversible. So you can come back to ice anytime you want, right? You just have to decrease the temperature or increase the pressure. You can you can do it by both the ways, right? Okay. Now the thing is, so the thing is like the molecules, the composition is just the same, isn't it? So during a physical change, the molecular composition remains totally same. So no new substance is getting formed. Actually, what happens is the states of matter changes. The state of matter changes actually. The state of matter is getting changed. No new substance is getting formed. The state of matter is getting changed actually. So the formula remains same throughout the chemical change. The formula remains just the same because most new substance is getting formed, right? H2O is ice, H2O is water, H2O is vapor. So this is a physical change. Okay. For example, the molecular composition of ice and water is not changed. Got it? Okay. Now, if you move on to this slide over here, the energy needed to bring a physical change is equals to the amount of energy required to reverse the change. Now, ice to water. If I consider that I have 1 gram of ice, I want to convert it into 1 gram of water. Fine. Okay. So I need, let's say I need 100 calorie temperature. Let's say I need 100 calorie temperature. Don't get me wrong. I'm not saying that ice is in 0 degree centigrade. Okay. For 0 degree centigrade, we use a latent heat of, fusion and all, and I'm not going there. Okay. This is completely a different thing. I'm not mentioning the temperature here. So let's say I have 100 calorie. I have to use 100 calorie per gram. This much amount of heat to convert a 1 gram ice to 1 gram water. Got it so far? Now, if I just heat ice, I would get water. My point is, if you take out 100 calorie heat from water, won't you get the ice again? Ice back again? So it is not only reversible. The thing is, if you just if you just reverse the reason why this change is happening, the change is going to get reversed. Think about switching on the light. When you are switching on the light, what are you doing? You are just switching on the switching on the switch, okay, and the current is flowing through the wires, okay, and the light is turning on. When you are switching it off, the current stops flowing and the lights gets off. So that is the thing. It is exactly the opposite thing to reverse it back. That is the same thing happening here as well. You can see energy required to reverse the change is equals to the energy required to make the change. There is no change in energy, so the energy remains same. Okay, the changes are reversible and temporary. Ice is not going to be water for all the time. Like if the temperature decreases, it would get converted into ice again, right? It increases, it may get converted into vapor, which is called evaporation, isn't it? Now, I think I think you remember vaporize, like water gets into like converted into vapor, okay, at its boiling point. That's a true thing. But below its boiling point as well, water gets converted into vapor via evaporation. You know it, right? Now you can see so many changes are written over there. So you can see this is sucrose. Sucrose is nothing you don't have to worry about. Sucrose is C12H22O11. For those who don't know what is sucrose, let me tell you, the sugar you have in your kitchen, that is sucrose only. Okay, fine. So that is a disaccharide. Okay. Now, when you dissolve it in water, what is happening? The sucrose particles are getting perfectly dissolved in it. And we call it dissolution, right? Now, if you want to take that sucrose back, you just have to heat that water so that it gets evaporated. So, dissolution is a physical change. Okay, got it? Now, if you just think about it, this is nothing but the formation of ice, isn't it? Or crystallization, formation of crystals, I should rather say. This is also a physical change, right? The formation of crystals. If you just heat it, it would just break down. And this is melting of ice. I don't need to say anything anymore, I guess. So all of these things are physical changes. Okay. Now, the chemical change. Okay. Now, what is a chemical change? The chemical change, the changes in which the molecular composition is completely changed, and the new product is formed, is called a chemical change. A new product is formed. So what do they mean by this word? Like a new product is formed. What do they mean by that? Let me give you a very good example to understand the physical change, the chemical change, I guess. Now, think about it. Hydrogen. We know that hydrogen is a very good inflammable substance, isn't it? Inflammable substance, right? It catches fire very easily. Oxygen. Why is oxygen famous? Because it is a supporter of combustion. Because it's a supporter of combustion, isn't it? When they mix up, when this hydrogen and oxygen mix up, they give us water. Now, water, on the other hand, used to extinguish fire. Isn't it a tragedy? Think about it. When the hydrogens are reacting with oxygen to give you water, this thing, these are the hydrogens and this is the oxygen, and this thing is called a chemical bond. Okay, whenever chemical reaction occurs, these things are getting formed there. Now, hydrogen is an inflammable substance. Oxygen is a supporter of combustion. When they mix together, they are giving you water, which is helping us to extinguish the fire. So I think you can understand it is showing exactly the opposite nature. So a chemical change forms a new compound. Chemical change forms a new compound. This is something new that has nothing to do with its constituent particles. So you don't even think about it that water is going to show the properties of hydrogen and oxygen. Never. Water is never going to show the properties of hydrogen and oxygen. It is completely a new substance there. Okay. Maybe its formula contains hydrogen and oxygen. That doesn't mean it shows the properties of hydrogen and oxygen. It has a new property, new sets of property, new sets of skills, new physical properties, new chemical properties, new looks, new boiling point, new melting point. Everything is new. It is completely a new substance. So let me tell you, like it's like Completely like when you just throw away a plastic. Okay, when you just throw away plastic, like it's a plastic mug. Let's just consider you have a plastic mug and you have thrown it away in a dustbin. And the people from the municipality, they are collecting it, and after that they're recycling it. And they're recycling it to a something to make something new. Let's consider that that is a container. Okay, a container. That is a container now. So would that container have any properties of that mug? No, right? Because that's a new compound now. So that is the same thing happening here as well. So chemical changes are going to make something new. And we cannot predict that what would be its property, what would be its physical property, how would it look like. We cannot predict any of it. So that is called a chemical change, right? A new product is formed. The changes in a chemical change are irreversible. After formation of water, if you just like change the like exactly reverse back all the all the processes through which you got water, you're not going to get hydrogen and oxygen. Irreversible is a very strong word over here used, but the thing is you can get water you can get hydrogen and oxygen from water, but that is not via exactly opposing the factors. You do hydrogen and oxygen, then what you have to do is you have to perform electrolytic decomposition. You have to perform this electrolytic decomposition. If you perform this, then it would get broken into H plus and OH minus. And from here, if you have a cathode and an anode, you have read it in class 8 only. Remember the electrolysis? You need a cathode and an anode, right? So the OH minus would go there and the H plus would go here. H plus would form H2 and OH minus would form O2. Fine, 4OH minus would release 4 electron to give you yeah, this is the reaction, right? Now, so this is another chemical change. So to reverse back a chemical change, you need to make another chemical change, but you cannot find it by reversing the factors only. This is the difference between them. During a chemical change, the energy changes occur. There is an energy difference between breaking of bonds of the reactants and formation of new bonds. So if I consider that this is H2, okay, it is going to react with O2. This is O2 and this is H2. To form, they are going to react to form H2O, which again looks like this. This is O2 and this is H2. Together they are going to react to give me this. Okay, now look at it. The first thing that they have to do is they have to break this bond, isn't it? They have to break this bond. They have to break these bonds. After that, they would react to give you this, the mixture. Okay. Now, to break this bond, you need some energy, isn't it? To break this bond, you need some energy. To break these bonds, you need some energy. On the other hand, while the formation of these bonds would occur, they would give you some energy. Are you getting my point? When bond breaking occurs, Bond breaking, it's an endothermic process. You need to give energy to it. Okay, the enthalpy is plus delta H. Delta H is going to be plus, positive. Okay, and for bond making, it is going to be exothermic. What my point? It is going to give you the energy, okay, for bond making purposes. So the difference in the breaking of old bond and the reactants and the forming of new bonds in products. Okay, so this is about the chemical changes. New substances are going to form, and there is some sort of, you know, thermodynamic parts as well. So you can see like endothermic and exothermic reactions, right? So bond making and bond breaking. Now all the pictures you can see in front of you, like burning, like digestion, these things. All of these are chemical changes. All of these are chemical changes. Okay. Burning is nothing but the reaction with oxygen. Okay. So every one of them are chemical changes. Okay. All of them are permanent changes. They are not temporary changes. They are permanent changes. Okay. Got it so far? Now let's watch a video to understand the concept even in a better purpose. Just give me a moment. Something's wrong, I guess. Let me check. Yeah, I think it's done. Just see. Yeah. So we were here, right? Yeah. So the thing is, yeah, in so far we are discussing about the physical and the chemical changes. I think you got it. And why the chemical changes are making new compounds? Why the chemical changes are making new compounds? Because of this chemical bonds only. Because of this chemical bonds only. So the thing, like this compound over here, this is methane in front of me. Okay. So why is this special? Because of this bonds only. This is what making it something new. Let's watch this video now. It's completely ready for us to watch. Can we make file fresh again? We cannot do that, right? So this is the chemical change. All of them are either physical or chemical. Okay, changes. This is how we set the ice, right, in our freezer. So it just freezes into ice, the water. So we already know about it, right? I have shown you everything, all the structure and everything about it. That is what they are saying. Only the physical form is getting changed. So you can see it over here, where the only the physical, like the change of matter, change in state of matter is happening. Okay, that is always a physical change because no new substance is getting formed there, isn't it? It can be reversed via heating, right? Exactly opposite. Look, there is a very big misconception about it, like the chopping of wood. So if this is a wooden block, if you're just cutting it into two halves, is it going to be a physical change, or is it going to be a chemical change? Which one? So as you can see, this process cannot be reversed, right? You cannot put that wood back on. So people gets confused over here. You're getting my point? This reaction is irreversible. You cannot take that wood back in the previous way, right? In the previous, uh, like it was looking previously. You cannot make it, right? It is now have two halves. But the thing is, if you just give it a closer look, is something new getting formed? Is something new getting formed? Is there anything new which is getting formed over there? No, right? Nothing new. Nothing is new over here. No new substances are getting formed. No new compounds are getting formed. So the broken wood have all the composition. So the broken wood have all the composition. Okay, the broken wood have all the possible composition which was there in the main wood. Clear? So all of them are physical change. So bending of wire. That is also. Breaking of a glass as well. Irreversible, but physical changes. So wood molecule remains same, isn't it? After getting cut from the tree. So when it is getting burnt, what is happening? So let me tell you what is the fact they are trying to tell you. So I'm just drawing it over here. So wood is nothing but carbon, isn't it? Wood is nothing but carbon. When you burn it, this is giving you CO2 or CO. Okay, these type of things. After cutting it is just a physical change. When it is burning, exactly. You cannot change back an ash to wood. So after new substance is formed, only then we can say it. Burning of paper, rusting of iron, cooking of rice, curdling of milk. Okay, all of them are chemical changes. Okay, that is the thing we are going to learn now. What are the differences then about the physical and the chemical changes? So the physical changes are mostly reversible. Most of the physical changes are reversible. Chemical changes are not reversible or irreversible, isn't it? No new substance are getting formed. Okay, one or more than new substances are formed. The substance retain its chemical properties. The new substances formed have different properties from the original substance. Okay, so this is about the physical and the chemical changes. Now we would get back to the some FAQ type questions. So which of the following is a chemical change? Physical change. Melting of iron metal. Okay, rusting of iron, bending of iron rod, drawing a wire from iron metal. So rusting of iron is a chemical change because this is nothing but a reaction with oxygen. Okay, dot H2O. Fine. Bending of iron rod. This is also physical change. Melting of iron metal. This is also physical change. Drawing of wire into iron metal. This is also physical change. 1, 3, and 4. Yeah. Option C should be right answer. Okay. I think after solving this question, you got the entire concept. Okay. So that's it for this video. I think you have enjoyed the moment with me and you have learned new things. If you have any doubt, you know what to do. You just write it on the forum. Thank you for your attention. I think we are going to meet each other in the next video as well. Okay. Bye bye everyone. Until then, keep on learning from Ask IITians. Bye for now.